has unmatched capacity to investigate an enormous exoplanet located over 1,000 light-years away, fulfilling an incredible dream for astronomers. Webb has found clouds of haze and unclear traces of water in a single observation made with the combined strength of, with its 270 square foot mirror accuracy, spectrophotometers, and delicate sensors. These findings were previously believed to be unfeasible due to prior observations. Webb's close to the infrared camera and cut the spectrograph was employed to produce the hot gases transmission spectrum. Massive WASP-96b, which only offers a brief look at the mission's fascinating prospects for exoplanet research. Find out more about this incredible findings from the James Webb spacecraft, observing through a telescope as the end of the episode for today. The steamy atmosphere of a distant exoplanet is disclosed by Webb, the signature of water vapor in the hot, puffy gas giant's atmosphere, traveling around a distant sun-like star possesses. Be taken prisoner by JWST. It also found evidence of clouds and haze. The most detailed observation of its kind to date highlights Webb's incredible ability to research thousands of atmospheres, light-years distant, based on modest decreases in the luminosity of particular light hues. It denotes the existence of specific Hubble Space Telescope gas molecules, has examined the atmosphere of several, over the last 20 years, exoplanets, finding water for the initial instance in 2013, but Webb's speedier and more comprehensive. An important observation is represented by progress in the endeavor to ascertain maybe livable planets outside of Earth. Over 5,000 have been confirmed. The Milky Way's exoplanets include WASP-96b. It depicts a certain kind of gas giant that has no equivalent in our solar system and is approximately a distance of 1,150 light-years in the southern Phoenix constellation in the sky. WASP-96b has a lot more puffiness than any other planet circling our solar that has mass that is less than half of Jupiter's, a diameter that is 1 or 2 times bigger than, is also notably warmer, sporting over 1,000 degrees Celsius, Fahrenheit degrees. A WASP-96b completes one circle of its approximately every 3.5 Earth days, circling it so closely because the distance is only 1/9 that between the Sun and Mercury. WASP-96b is an ideal target to aim for atmospheric observations because of large-scale puffy with a short orbital period, environment, and lack of polluting. June 21st, light from neighboring stars. Webb saw the WASP-96 system imaging in the near-infrared and slither spectrograph. For 6.4 hours, the nurse watched as the planet traveled across the star. Ultimately, a light curve that illustrates the general fading of starlight, both during a transmission and a transit. Spectrum that displays the luminosity variance of a particular infrared light. Wavelengths ranging from 2.8 to 0.6 microns. Although the transmission spectrum makes clear previously unknown information about the atmosphere, as confirmed by the light curve, characteristics of the planet that had previously determined by other observations, such as the fact that it exists, dimensions and orbit, the distinct water signature, clouds and haze that were based on previous findings. It was thought not to exist. The existing starlight passed through the atmosphere of a planet as it is compared to what passes in front of the star towards the pure starlight that is when the planet is next to the star to produce a spectrum for transmission. According to the pattern of absorption, the places the graph's peaks and heights. Researchers in science can recognize and measure the quantity of significant. The planet's atmosphere's gases, atoms and molecules differ in wavelength patterns that they absorb, comparable to how individuals have distinct DNA and fingerprints sequences. The spectrum of WASP-96b, captured by Webb's slitless near-infrared imager. The spectrograph nurse is not limited to Best near-infrared transmission accuracy. Spectrum of the atmosphere of an exoplanet to date yet. It also covers an amazing range of wavelengths, which includes visible red light along with a spectrum segment that was not previously available from additional telescopes, water and other necessary substances such as carbon dioxide, methane, and oxygen, which are not readily noticeable in the WASP-96b spectrum, although it ought to be observable in some exoplanets stand out in particular. Attentive to this section of the range, scientists will have the ability to gauge the quantity of atmospheric water vapor, limit the quantity of various components such as oxygen and carbon, determine the temperature of the atmosphere using the spectrum to provide depth, which Webb intends to watch. Utilizing the data, they can create conclusions regarding the general composition, in addition to how, when, and where the best-fitting model was constructed. Symbolized by the cyan line on the graph makes sense of the data that is known. Eigenschaften der WASP-96b und star. Also the attributes that are attributed to the environment. It is now feasible thanks to current web design for these dimensions to possess such extraordinary detail and clarity. The 270 square foot mirror with gold plating efficiently absorbs infrared radiation. Its perceptive infrared sensors identify remarkably little differences in luminosity, and its accurate spectrographs scatter light to create rainbows of many hues of infrared. NIRS is able to discern light distinctions between hues that are a few hundred fragments per million and color variations that are very slight. It spans 1,000th of a micron, wavelengths of infrared light that we possess never before had access to, which is thrilling. The exoplanet's infrared atmospheres been examined by more telescopes. Nevertheless, not with the same degree of detail. Yet this only makes up a tiny percentage of the information cited by Colin, a specialist in outside planets. Despite Webb's extraordinary steadiness, the location of Kit's orbit around Lagrange 2, and that roughly 1 million kilometer distance, kilometers apart from the atmosphere of Earth, permit for a continuous view and fast data examination. Just a little peek at what the Webb will. Exoplanet science is demonstrated by the extremely intricate spectrum produced by examining 280 distinct spectra concurrently. Spectrography will be used by researchers to look into the environments of several exoplanets with sizes ranging from tiny, rocky worlds to massive stars that are plentiful in ice and gas in the upcoming years. Exoplanet studies and the resources they produces accounts for over 25% of, in a single observation, the JWST cycle. This up-close observation shows the capacity of Webb to characterize extraterrestrial atmospheres of planets, including those that possibly livable for most of the. According to Antonella Nota, scientist JWST in charge of the European Office of the Space Agency in the Space. The Telescope Science Institution is scheduled to carried out with spectra, but we frequently assert that a picture speaks 1,000 words. Astronomers merely take into account spectra to be valued at 1,000 images, and thus concludes today's episode. All we can do is pray that James Webb mysterious discoveries made by satellite telescopes keep surprising us with new details regarding exoplanets. Give us a hearty thumbs up, and if you like this, please subscribe to our channel. What you observed. See you at the upcoming